All right. All right, ladies and gentlemen, we are going to get on to our last lesson of the year. Not exactly how I wanted to end it out, but we'll go with it. Um, so what we're going to do is look at a theorem here that'll help us out if you're going to go further on into trig. We are not, um, because of the situation we're in. So what we're looking at today is de Moivre, however you want to say it, theorem. Um, so what we're going to do this today is we're just going to look at de Moivre's theorem to find powers of complex numbers. We are not going to do the nth roots of complex numbers. I need you in class to be able to do that. You guys will have a lot of questions. It's just not going to work. So here we go. Powers of complex roots. So a lot of talking here. Blah, 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 blah. Goes on and on some more. But what de Moivre's theorem says is if I have z to the nth power, I can just take r to the nth times cosine of n theta plus I sine n theta. I take a minute, write this down. You'll want it for your chapter test and chapter final. So here we go. I need to use de Moivre's theorem to find -1 plus square root of 3i to the 12th power. So the first thing I'm going to do is find my r value. R value is just the square root of -1 squared plus square root of 3 squared. That is 1 plus 3, which is square root of 4, which is just 2. So I got my r value is 2. So now I need to find my angle. So I know my angle is just tan inverse of square root of 3 over -1. And when I look at my trig table, tan inverse of negative square roots of 3, that's just 2 pi over 3. 2 pi over 3. So now, that was my scratch work. I can start to think of this problem. So I'm taking z to the 12th, which is equal to -1 plus square root of 3i to the 12th, which is just 2 to the 12th times, then it's going to be cosine of 12 times 2 pi over 3 plus I times sine of 12 times 2 pi over 3. Well, 2 to the 12th, this is 496. 12 times 2 pi over 3 is cosine of 8 pi plus I sine of 8 pi. But now I can simplify this. Cosine of 8 pi, well, that's just cosine of 0. And sine of 0, cosine of 0 is 1 plus 0i. Simplify this. This answer is just 4,096. 4,096. Okay, it's pretty straightforward. Next one here. Again, same thing. R value, square root of 1 squared plus 1 squared, which is square root of 1 plus 1, which is square root of 2. Can't simplify. We're going to leave it like that. And then theta equals tan inverse of 1 over 1. Tan inverse of 1 just gives me pi over 4. So now I know that I'm trying to find z to the 5th, which is equal to 1 plus I to the 5th. Well, this is equal to my square root of 2 to the 5th times cosine of 5 pi over 4 plus I sine 5 pi over 4. Now, I had worked this problem out, but I had screwed up on my calculator. I had done everything to the 12th power for whatever reason from the last one. Square root of 2 to the 5th. This is 5.7. Cosine 5 pi divided by 4. Got to find my unit circle here. Give me a second. Cosine of 5 pi over 4 is negative square root of 2 over 2 plus I times negative square roots of 2 over 2. And I'm actually going to backtrack a little bit here. The reason I'm going to backtrack is this one will work out kind of nice for us. I'm going to leave this as square root of 2 over 5, because now when I whoop this, square root of 2 over to the 5th times square root of 2. That just gives me square root of 2 to the 6, negative square root of 2 to the 6 over 2 plus I times negative square roots of 2 to the 6 over 2. That's square root of 2 n to the 6th power. That just becomes negative 2 to the 3rd over 2 minus, I'm just pulling that minus out front, 2 to the 3rd over 2i. And this is just going to simplify to be negative 8 over 2 minus 8 over 2i. That just simplifies to be negative 4 minus 4i. So negative 4 minus 4i. One more of these. Last trig lesson of the year. We're going to use de Moivre's theorem to find 2 plus 2i to the 6th. So I'm just going to start r value 2 squared plus 2 squared, which is square root of 4 plus square root of 4, which is square root of 8, which is, I'm just going to leave it as square root of 8 for now. Now, my theta tan inverse 2 over 2. Again, that's just 1, so that's pi over 4. So now I can start working on this one. So I'm trying to find z to the 6th, which is 2 plus 2I to the 6th, which is my square root of 8 to the 6th, which is multiplied by cosine 6 pi over 4 plus I sine 6 pi over 4. Square root of 8 to the 6th power is 512. I'll just double check that number. It is. I just doubting my math after I screwed up on the last one. That's cosine of 3 pi over 2. I'm just simplifying. Simplify this some more. 512 cosine of 3 pi over 2, that's 0, not a comma, plus this would be a negative 1. So now I'm just going to distribute. 512 times 0 is gone. 512 times that negative 1I, gives me negative 512I. That's my answer. All right, guys and gals, that is it. That's de Moivre's theorem. Like I said, there's some other stuff that if we were in class, we would work on, but we cannot right now. So work day, the next day of class, I'll be around for questions. If you have anything, let me know. Have a good day. Talk to you later. Bye.